Hi there. This video is an exam paper walkthrough of the Eduqas GCSE Mathematics Foundation Tier Component 1 paper from autumn 2022. This paper is worth 120 marks in total, and this is the third video of 6. It will focus on questions 10 to 13, which account for 20 of these marks. Eduqas Component 1 papers are non-calculator, so a calculator should not be used. A little disclaimer: there may be more than one way to answer a question. The methods shown in this video are not the only way some mathematical skills can be applied. Okay, let's get started. Question 10. Nico's normal pay rate was £20 for each hour that he worked. Nico normally works 35 hours each week. Any extra hours that Nico worked were hours of overtime. And Nico's pay rate for each hour of overtime is 1.5 times his normal pay rate. Part A, show that Nico earns £700 in a week when he does not work any hours overtime. So this is what we're looking for. If there's no hours of overtime, we're looking for what he normally earns before they pay him any extra. Okay, so his normal pay rate is £20 per hour, and he usually works 35 hours a week. So we are doing 20 times 35. Now, how you do this is up to you. You can use the grid method or whatever. So I'm just going to partition this, okay? So I'm going to split 35 up as 30 and 5 and times both of those by 20. So 30 times 20. 3 times 2 is 6, but then we've got 10 times bigger and 10 times bigger. So that's 100 times bigger, so that must be 600. 5 times 2 is 10, but that's 10 times bigger, so 100. And then we're going to add those together. So 600 plus 100 is £700. So that is what Nico normally earns in a week. So we've shown that he earns £700. Part B, 1 week, Nico worked for 38 hours. Calculate his pay for this week. Okay, so in a normal week, he works 35 hours. Anything over that is overtime. So he does 35 normal hours, but then 38 take away 35. 8 take away 5 is 3. And then he's got 3 overtime hours. Okay, so the difference between what he normally works and what he did work tells us his overtime hours. That's an awful 5, I'm so sorry. So 35 normal hours and 3 overtime hours. Okay, so we're going to calculate his pay now. So his normal hours are £20, okay? So 35 times 20, well, we've done that up here, so we're not going to do that again. So for his normal hours, he's going to get £700. But for his overtime hours, he gets 1.5 times his normal pay rate. So for his overtime hours, he's going to get his £20 per hour plus half of that again. So half of £20 is £10. So for overtime, he gets paid £30 an hour. So we're going to do 3 times 30, which is 90. That's his overtime pay. So we're going to add that 90 to his normal pay of £700. So he earns £790 in that week. Okay, the next part. The next week, Nico earned £1,060. How many hours of overtime did Nico work? And we've got to show all our working. Okay, so we know from part A that in a normal week, he earns £700 for 35 hours. So let's get rid of that from here. Let's take away 700. Okay, so 0 take away 0. 0, 6 take away 0, 6, 0 take away 7, we can't do and get a positive answer, so we're going to have to borrow from here to make that 10, 10 take away 7 is 3, so he's got £360 of overtime pay, okay? Now we worked out here that his overtime pay is £30 an hour, so we need to do 360 divided by 30. So I'm using the bus stop method here, guys. And I'm going to do some of my 30 times tables there to help me just in case I need them. So I'm going to do 30 into 36. Well, 30 goes into 36 one time. And to get from that 30 to 36 is a remainder of 6. So now I'm doing 30s into 60. So that's 1, 2, There's no remainder, so that tells me that he works 12 hours of overtime that week. Okay, part C. The following week, Nico's normal pay rate increased. So his normal pay rate increased, he gets a pay rise. He did not work any hours of overtime, and he earned £735 for that week. Show that Nico had a pay increase of less than 6%. Okay, so let's go back to the original question. Normally, before this pay increase, he earns £20 per hour. Okay, so the starting rate was £20 per hour, and that would earn him £700 in a week. Okay, so this time he's earned, sorry, my dogs are going mad. Yep, so that earns him £700 a week. This time he's earned £735 here. So we're going to see what the difference is between how much he's earned. So we're going to do 735 take away 700. So that tells us that he's earned £35 extra that week. Okay, so we're going to work out what 35 out of 700 is as a percentage. So we're going to write it as 35 over 700 because it's 35 out of 700. And then we're going to simplify. So we're going to look for a number that we can divide the numerator and denominator by. Now, they both end in a 5 and a 0. If anything ends in a 5 and a 0, it can be divided by 5 if it ends in a 5 or a 0. So let's divide by 5 to start off with. 35 divided by 5 is 7. Do the same to the bottom. 700 divided by 5. Well, there's 25s in every 100. And there's 700s. So 7 times 20 is 140. Okay. Now I know that 7 and 14 are both in the 7 times tables, and if 14 is in the 7 times tables, then 140 will be in the 7 times tables. So I'm going to divide by 7. There may be a quicker way to do this, but I'm just doing it the first thing that my brain spots. So 7 divided by 7 is 1, and 140 divided by 7 is 20. Okay, we want to know what it is as a percentage. A percentage is out of 100, so we're going to scale it up this time. Okay, guys. So to get from 20 to 100, we times by 5. So to get from 1 to the new numerator, we times by 5. So this here tells us that it's a 5% increase. Now, you might have said to yourself, well, what are you doing, Miss B? Because 35 and 700 are quite clearly in the 7 times tables. But what I've just done is shown you that actually your brain doesn't think like that sometimes straight away. So the first thing I spotted was 5, so I went with it. Had to do a few more steps, but it doesn't matter, all right? But we've shown that this pay increase is less than 6% because it's actually 5%. Okay, next part of, so part 2 of C. Dana works with Nico. They work the same number of hours. Dana had a pay increase of 6%. She says my pay went up by a greater percentage, so I earn more than Nico now. Explain why she may not be correct. Okay, so if they earn the same, so if they earn exactly the same hourly rate, okay, then her 6% increase is higher than his 5% increase. Okay, so she would earn more. But she could also have been earning less per hour than Nico. So you can either say if she was earning less per hour, then she might not be correct. Or you can say it would only be true if they're earning the same. I'm going to mention if she earns less. So Dana could be earning less than Nico before the percentage increase. Question 11. Ari has a biased spinner. The numbers on the spinner are 1, 2, 3, 4, 5, 6, 7, 8 and 9. The table shows the relative frequencies of some events using Ari's spinner. So the event is across here and then the relative frequency. So the relative frequency just shows us the chance, like how often that event happened. So on the spinner, RE got a number less than 5 is a 0.75. RE landed on 5 is 0.1, and a number more than 5, there's a blank for that. And it wants us to find, oh dear, the relative frequency of spinning a number more than 5. Okay, so the key we need to recognise here, guys, is probabilities have to add to 1. Remember that probability scale goes from 0 to 1. Impossible, certain, and all of the possibilities between that, okay? So they've got to add up to 1. So we're going to take these two things away from 1 to find the missing number. So I'm going to start by adding them together. Be careful here, guys. This is 0.75. This is 0.10. Make them look the same length. So put that 0 placeholder in so that you line things up in the correct place value columns when you're adding, or you're going to go wrong. So we're going to add these. That's 5. That's 8. So 0.85. So then we're going to take that away from 1. Again, 1 is 1.00, and we are taking away 0.85. Okay. 0 take away 5 we can't do and get a positive answer. We would borrow from here, but that's also 0. So we're going to have to borrow from here to start off with. So when we borrow from here, it becomes 0, but it makes the next column 10. That's what's important, guys. And then we borrow from this column to make it 9 to make this column 10. So 10 take away 5 is 5, 9 take away 8 is 1, 0 take away 0 is 0, and that's when my decimal point goes. So the number more than 5 is 0.15. These probabilities now add to 1. Question 12. The table shows some of the values of y equals 4x subtract 1 for the values of x from -1 to +1. So this inequality here just gives us our range of x values, -1 through to 1. And then this is our equation. And what's happened is they've substituted these x values in to find these values. And for part A, they want us to complete that table. So we're going to do the same. We're going to substitute those values in. Now, this is a linear graph. So you can actually treat it like a sequence, okay? Or you can substitute. There's two ways to do it. So because it's a linear graph, all right, we can spot the difference between these two terms. So from 1 to 3 is 2, and work backwards by subtracting 2. So 1 subtract 2 is -1, subtract 2 again is -3, subtract 2 again is -5. So just be aware that you can do that, okay? So the difference between these two is 2, which means the difference between these two must be 2, and the difference between these two must be 2. And then the difference between those two. The other way that you can do this is you substitute in. So you find y when you substitute in an x value. So here, y equals 4 times something subtract 1. Well, if that's something 0, you put a 0 there. So y equals 4 times 0 subtract 1. Anything times 0 is 0. 0 subtract 1 is -1. So that's where the -1 comes from, okay? Doing it like sequences, so spotting the pattern, so going this way we add, working backwards we subtract, is easier than then having to substitute in -0.5 and 0.5. So it's just something to be aware of. 2 marks there, 1, 2. All right, part B. On the grid below, draw the graph of y equals 4x subtract 1 for the x values from -1 to 1. So these match up here. Okay, so we're working with this table. Now, you actually only need 2 points to draw a straight line, but we have 5 points here that we need to make sure that that line goes through. So what I'm going to do is I'm going to plot this coordinate and this coordinate, okay? So this is x coordinate -1, y coordinate -5. So we're going to go across to -1, down to -5. Now, remember, you would use a pencil for this. I'm using a pen so you can see it nice and clearly on this recording. Okay, and then I'm going to plot this coordinate. So the x coordinate is 1, the y coordinate is 3. So 1 and up to 3 there. Look, we're halfway between. Now, if I draw a line between these two with a ruler, because it's a linear graph and I have to draw a straight line through, and if I make sure it covers the whole of the graph like that, we can double check, but I should have covered the other points. So when x is 0, y is -1, 0, -1, that works. When x is 0.5, y is 1. X is 0.5, y is 1. So just with those 2 points and our nice clear straight line, we've dealt with all of those coordinates there for those 2 marks. Question 13. Kit paddles a canoe out to sea from the point marked S. So he's starting here at point S. He stops when he is on a bearing of 160 degrees from S, and he's also 120 metres from S. Use the scale diagram below to find Kit's distance and bearing from T when he stops. So distance and bearing from T when he stops. We've been given a scale here. 1 centimetre represents 20 metres. Okay, so we need to draw these two. Or construct these two criteria on this diagram. So we are going to need a protractor and a ruler, and obviously you're going to do this in pencil on your exam paper, guys. I'm going to do it in pen, hopefully not make a mistake, so that you can see it nice and clearly. Okay, so the first thing I'm going to work with is this bearing of 160 degrees from S. From S means this is where I'm measuring my bearing from, okay? So what they've drawn for us, lovely, is a north line here. So that's where we're going to start measuring 160 degrees from, okay? We're going to take our protractor. We're going to take this middle point of our protractor. Yours might look different, but you'll have a middle point, or you might have a little circle that's a gap that you need to try and put that circle in. So that middle point is going to go on the dot where S is, and then this 0 line here is going to be aligned with my north line. So we're going to start by doing that. So as accurate as we can be. So my middle, where my protractor lines cross, is on my S dot, and my 0 line here that starts the measurements on the protractor is aligned with that north line. So we're going on a bearing of 160 degrees. Bearings need to be read clockwise, so that's why we're reading in this direction. And we're going to 160 degrees. Well, I'm going to read around the outside numbers here, because that's the direction I'm going in. So when I move round, 120, 30, 140, 150, 160. So I'm going to mark a really clear point there, because that direction is a bearing of 160 degrees from S. Okay? The next thing we're going to do is find out where 120 metres from S is, and we're going to have to work with this scale here, guys, okay? So I'm going to go down to my working out at the bottom here, because we know that I like to use a proportion table, because it just organises my thinking a little bit. So this scale, 1 centimetre represents 20 metres, so we're dealing with centimetres and metres. 1 centimetre represents 20 metres. We want to figure out how many centimetres for 120 metres from S, okay? So we want our metres to be 120. Remember, when we're using a proportion table, we are scaling up or we're scaling down. 120 is bigger than 20, so we're scaling up, which means we've multiplied. Okay, well, how many times do we multiply 20 to get to 120? Well, 12 divided by 2 is 6, so 120 divided by 20 must also be 6. So we've times by 6 on this side. So we're going to do the same on the other side. So 1 times 6 tells me that 120 metres is 6 centimetres. So I'm going to go back to here, and I'm going to use my ruler this time, guys, okay? So I'm going to put my 0 of my ruler on S, and I'm going to align my ruler with the dot that I placed for my 160 degree bearing. So we want it to be on that bearing and this distance, okay? So I'm using my pen on the dot there, because then I can align my 0 with my pen and then keep it there while I'm moving to align with this dot that I placed for the 160 degrees. Now we worked it out to be 6 centimetres, so from 0, 1, 2, 3, 4, 5, 6. So this is where T is when he stops. Now you can draw a faint line if you want to. Nobody's going to judge you for that. So this is where Kit is when he stops. Sorry, I just said T and I didn't mean that. So that's where he is when he stops. 160 degree bearings, and that's 6 centimetres, about 120 metres. So this is where he stops paddling, okay? Now we need to use this point here, and we want to find his distance and bearing from T. So we want to know how far he is from T and on what angle he is from T, okay? So what I'm going to do to start off with to make my life easier is I'm going to join T and where Kit stops up, okay? Make it nice and clear that's where he stops, because they're going to check your constructions. They're going to check your bearing and your measurements, guys. You get a little bit of leeway either way, but be as accurate as possible. So the first thing I'm going to do is I'm going to find my distance, okay? Because that just requires me to measure this line and then do some converting, all right? So let's draw myself another proportion table just to figure out the distance from T. So this is where we're working from T here, so I'm going to put that there, and that's where we were working towards stopping, just so we don't get confused with our working out. So centimetres and metres, 1 centimetre from our scale is 20 metres. So let's measure up how many centimetres from T he stops. So again, I'm going to put my pen there, put my 0 on, and then I'm going to do that, and then to here, 7.5 centimetres, 7.5 centimetres, okay? So remember, we scale up or we scale down with a proportion table. So 7.5 is bigger than 1, so we've multiplied. And 1 times 7.5 gives me 7.5. So now I need to do the same to the other side. So 20 times 7.5, okay? I'm going to use some space down here because I have space. So 20 times 7 and 20 times 0.5. 7 and then 0.5. 20 times 7, well, 2 times 7 is 14. So 20 times 7, 20 is 10 times bigger. So that must be 140. 20 times 0.5 is the same as halving 20. Okay, so half of 20 is 10. So we're going to add those together. So that gives us 150 metres. So he's 150 metres from T. We now need to find that bearing. So we need to measure a bearing from T. So we're measuring this angle from the north line all the way around to that line we drew there. Now what we need to recognise is my protractor is only half a circle. It's a semicircle. So it's only going to go to 180 degrees. And then I've got a little bit extra I need. So I'm going to make my life easy here, guys. Okay, I'm going to put my ruler aligned with the north line. And then I'm going to draw myself a line down here. Because that is 180 degrees. I know that because that's my half of a circle. So I'm interested in this extra little bit here, then I can add it to 180. So what I'm going to do now is turn my page and I'm going to put my protractor like I did before, the middle part on T. I'm going to align my 0 line with the line I've just drawn because it's aligned with the north line. So let's do that. In the middle, align it with the line you just drawn, and then we are measuring around to this line here. So from here to here is 20 degrees. So if I turn that round, it's 20 degrees. I want the total bearing, so I want all the way round. So I want 180 plus 20 for this bearing. So 180 plus 20 is 200. So my bearing from T is 200 degrees. Be wary with bearings, you have to give them as 3 figures. So if that was less than 100, I would have to put a 0 in front to make sure it's 3 figures. But we're okay here with these two.